Welcome back. So let's go ahead and actually attempt to read and write the function read process RAM. So the first thing that we're going to need to do is type in get process handle. So we're just going to go into the main, and I'm just going to type in handle p handle equals to get process handle, and I'm going to need to pass a PID, which I will cut from here, and just type in PID. I also had functions for basically fetching the PID of a running process, but I figured I wouldn't burden you with that much in this short teaser, I guess. So I just need the PID, and well, we're gonna need the PID of a process, but we're gonna get that in a bit, and then we're gonna initialize. We cannot leave it uninitialized. That would be terrible for us. The next thing that we need is a address. So long ADDR, we're gonna leave that uninitialized as well, which we will need to initialize, of course. And then we're gonna go ahead and type in read process memory. Oh god. Read process memory. And the first parameter is a handle. So let's just type in p handle. The next parameter is a base address. So let's just, but it needs to be of a certain type. It needs to be LPC void. So let's just type in LPC void and type in here ADDR. Okay. So the next thing that we need is a buffer. So this is the address from where we read. Now we need to know into what we are reading. So let's just say int buff. So this will be our buffer into which we're going to read. And we need to know what type of data are we reading so that we know how much of it to read. So this, we're just gonna type in int buff, and this actually requires an address, sorry. And after that we need the size. So the size of this type. I'll basically just type in size of an int. And lastly, we need to have number of bytes that we've actually read. This value is used for troubleshooting. So I'm just going to name it read size. And I'm going to go up above. And, well, I'm just going to group them up here as one. So this will be a size D. Read size, and we're gonna leave that one uninitialized. So what is the problem? Argument of type is incompatible with the parameter st. Okay, let's try this the other way around. Size t size t. Right. Okay, and now I need the previous one. Perfect. There we go. Anyway, so now we have read process memory. So this has the handle to a specific process whose RAM space we're going to read. This contains the address within that RAM space which we wish to read from, which is the starting address from which we'll start the reading process. This is actually our buffer, so we'll actually read into it. So whatever we find at this address, we're going to put into int buff. And the size that we're going to read cannot exceed the size of int, so we'll just say size of int. And the last variable, so we don't need to actually do anything with it. We can just use it later on for troubleshooting. So if you have a specific size which you wanted to read, you can check whether you've actually read that size or not, and then see whether or not that has actually been read. Anyway, down below, just gonna type in std cout, and this will be an int buff std and l, and here I'm just gonna say like this, health. I did not include IOStream, apologies. Perfect. So yeah. Okay, so now that we have all of this, what do we need? Well, we need the PID and we need the address within the process from which to read. The address we're gonna get by using cheat engine, and the PID we're gonna get by using the task manager. But in order for us to be able to get either one of those two, we actually need to run the program itself. The program needs to be running. Okay, let me reduce its size. Like so. I'm just going to go ahead and put it here. And I no longer need this. What I do need is the task manager. So console application 3, I don't know how you named your program, so whatever the name of your program is, just find it here. You can go, you actually need to go over to details, console application. Let me see, what number is this? Okay, so it's 28556. 28556. So that's the PID, simple enough to acquire. And now for the address. The address is a bit trickier, but we can get it with a cheat engine. You just see some sort of value here. So the current value of a health is, well, before I do that, I need to actually select a process right here. I don't need to keep it. And okay, so let me just take this value. Let's new scan, first scan. Okay, I found it. Let me put it down below. Take this address. I mean, you're not going to find it from the first try. You're going to need to do a lot more modifications. But for this short teaser tutorial, I do believe that it is enough. And we're just going to put that into the address here. But since this is a hexadecimal notation, we'll need to put 0x in front. And then let's go ahead and run this program and see whether it actually gets the value that we wanted it to get. Okay. First time I'm running it, so errors are possible. Well, no errors, but it just finished and exited. Okay, let's just give it a pause. The token does not have specified privileges. SE privilege failed. Error code 1300. Health is 87649. 87649. Okay, so the portion of the code did fail, but it did manage to actually read the health regardless. So maybe we didn't actually manage to set all the privileges. Maybe, I'm not actually sure what happened. We can investigate in the follow-up tutorial and see what actually happened. Let me just increase the size. As I said, this is the first time I ran this code on this machine. And it says error code 1300, and it actually managed to read the health. So in the follow-up tutorial, we're going to have a look at how to actually figure out what the error is and go over to the MSDN and see what the error actually means. But as you can see, it actually worked out regardless. Okie dokie, so I'll see you in the follow-up tutorial where we will do more than just reading the health. We'll actually attempt to modify it. I'll just leave everything running and as is.